Today we are going to discuss about properties of matter. So hope everyone aware about what are the three different states of matter and how these three different states of matter have an impact over the surface based on external influence, and the nature of external influence, how the impact of influence have over the surface with reference to different nature of forces. So these are the things we are going to discuss in today's session. Based on this, we will be having a kind of ice-breaking session. How an object can have an impact. For an instance, if you are going to have a tight slab over a surface of the floor, how we will feel? Whether the force excreted over the surface of the slab or the force experienced by our hand. So this is the major course equivalence what we will be doing today. In connection with this, how the nature of force will have an impact on the specific surface of the material. Fine. Let me share few pertaining forces have a real impact on the surface of force. So-called properties of matter. How a specific solid object will accept the external influence of force. At the same time, how the force created an impact on the surface. We will discuss today about the effect of force called stress. As a consequence of stress, how strain will be generated on the surface and what are the types of stress, as well as the relationship between stress and strain diagram. Shall we move to the class? Okay. So this deals with the properties of matter as informed earlier. Okay. The solid body has been classified based on many factors. The major one is about elasticity. That is how flexible your body is applicable to the external forces. There are two categories based on this. One is perfect elastic body, another one is perfect plastic body. That is, when we are applying a force on the surface, it will tend to react over it. That is, after the removal of it will create an impact, it will deform from its position. If it is an elastic body, though we have removed that applied force, it will regain back to its original position. That is known as perfect elastic body. When we are coming towards a plastic body, the deformation is permanent. After applying the external field of force over a body, it will stay as such. It will not come back to its original position. That will be constituted as a perfect elastic body. You can observe this in this animation frame. How a perfect elastic body have an impact over the surface. That is, after removal of force also, it has the ability to get back to its original position. When it comes to a perfect plastic body, a permanent deformation will occur. So these are the major classifications based on a plastic body. Let's move to the next one. Stress and strain. What is called a stress? Stress is a force which acts on a specific area. Stress is a force which acts on a specific area. That is, restoring force per unit area which bring back the body to its original state from the deformed state. For an example, where we are having a cube over here. That cube, when we are excreting a force over the surface, it will impact over the surface and construct it. That is, the force construction will be happening over the surface. Then there will be a discharge of force. After removal of force, it has to come back to its original position. Then what it would be called as elastic body. If it stays in the deformed state, then it will be called as the plastic body. So stress is a restoring force per unit area. That is, amount of force applied over the particular surface area will be considered as a stress. So based on the effect of stress, we are classifying stress into normal stress as well as tangential stress. That is, stress applied over a surface area normal to the surface is known as normal stress with respect to an angle of 90 degree. When we are applying a stress over the surface, listen carefully, when we are applying surface over the surface towards a specific direction is known as tangential stress, as like this. That is, the stress will act tangentially over the surface, not normally. That will be considered as tangential stress. Okay, we have discussed about stress. How stress will have an impact on the surface. Based on the stress, consequent results will happening on always in physics. That is known as strain. What is called a strain? It's a change in dimension produced by the external stress with respect to the body from its original position. That is, a small kind of deformation or a small change in dimension with respect to its original dimension, either in terms of length, either in terms of volume, either in terms of surface or angular deformation. That is known as strain. That is, it is defined as the change in dimension produced by the external force applied over the body. It is also referred as change in dimension to the original dimension. That is, it will be considered as a ratio between change in dimension to the original dimension. So there are three types of strains. One is longitudinal or tensile strain, that is change in length without change in shape. The length alone will be getting changed. Another one is shearing strain, angular deformation produced by the body due to the application of tangential force on it, as we have discussed in tangential stress, how the strain occurring with respect to the tangential force. The next one is volumetric strain, that is the change in volume with respect to force applied without change in its shape. Change in volume with respect to the applied force without change in its shape. So we will have a animated related things. Next one is Hooke's law, where Hooke's law will provide you a relationship between stress and the strain. How stress will create a strain, at the same time how strain will react for the applied stress. The relationship between stress and strain will be provided by Hooke's law. So what it states, stress is directly proportional to strain. For an instance, when let us observe this graph, when we are providing a stress continuously, the strain will also getting increased. When we are providing stress continuously, that is, the stress is along the x-axis and the strain is along the y-axis. So when we are providing stress across x-axis, there will be a generation of strain across y-axis. So where we are increasing stress, then there will be a increase in its strain. So it has two major things. One is elastic limit. That is what we tend to call as elasticity, getting back to its original position from its deformed state. Every material has its own elastic range. If we are providing stress beyond that elastic range or limit, it tends to move to its plastic range, plasticity. That range will be considered as elastic limit. That is the maximum stress up to which body can recover to its original shape and size after the removal of external forces. Then yield point. If the load is beyond the elastic limit, Hooke's law will become invalid. That is, in this particular place, it will become invalid. That is, it reaches its plasticity, then it tends to break. What we have discussed about Hooke's law, stress is directly proportional to strain. After the influence of stress, how much strain will be generated on the specific purpose, both the things will be proportional to each other. If there is a variation with respect to stress or strain, the graph will have a better inference. It has 2 points. One is elastic limit, another one is yield point, right? So based on these facts, we can identify the nature of material, whether this material will behave stress up to this limit and strain up to this limit. So this is the necessity of studying Hooke's law. Next one is elastic fatigue. If let us assume how much stress a specific hand can withstand. For an example, if my hand can able to withstand a specific limit of 3 kgs, it has the ability to withstand only up to 3 kgs. It cannot go beyond that. If I am applying a load up to 4 kgs, it will move slow. It will move up to elastic limit. Then it will move to plastic limit when I am supposed to increase the impact of load. Furthermore increase, it will lead to a fatigue, that is damage to a specific hand. If the load is about 5 kgs, the hand will get damaged. So that is known as fatigue. If a body continuously subjected to stress of any kind of solid body, it gets weak, and this is called the fatigue. So here is the important topic what we are going to discuss today, which is known as stress strain diagram. How stress will offer for a specific one for a specific solid object. Based on that stress, how strain will be calculated, and based on the applied stress, strain may vary, depends upon the load nature. That will be considered as a stress strain diagram. For an instance, let us assume this graph. In this graph, strain across the x-axis and stress across the y-axis. Clearly listen about this. Stress 0, strain is also 0. Where we are applying the stress, it is getting increased slowly up to the object A, so called perfectly elastic. When we release the stress at this point where the pointer has been placed, it will come back to its original position, so called origin. When we are increasing the stress, it will elongate, right, as per the stress relation. This particular point is there, right? This is known as elastic limit. Within this limit only, the specific solid material will act as a, within the specific limit only, this material will act as a elastic one. That is, it will not undergo any kind of deformation. Even if you remove stress also, it will come back to its original position. But after increasing stress beyond this point, it may move to its plastic region, where it can move to a deformation state based upon the increase of stress. Yield point, elastic limit, and this one is yield point. Then we are disgracing it to its A to A dash and rest of things. Then A to B is yield point. When it comes to it, it will create a certain states of deformation over the surface, like crack or rest other things. When it comes to a plastic range, C to D, it will completely behave as a plastic. That is, it will not come back to it. It will stay in the deformation state. So if we are continuously exposing the specific material towards a high yield of stress, so it will completely expose to a plastic range. Then when we are furthermore applying the stress, it will go to a tensile state. Tensile is an improbable state where it can break or it can weaken the nature of material. Tensile, it can break or it can weaken the nature of material. Furthermore application of force towards this will called as breaking stress, where the specific stress will have a bad impact over the surface of material by increasing the nature of its deliberations. So this is the stress strain diagram. For example, how much stress can be applied to a specific material? For that stress, what are all the respective strain points we can able to assume? First one is elastic limit, next one is yield point, the next one is plastic range, further one is tensile strength, and the another one is breaking point. That is, for various effective nature of stress, how this have a bad impact over the surface, and the bad impact over the surface, how it has created a different strain points. That is, the first one is elastic limit. Within that limit, it will act as a elastic material. When it goes beyond that is it will behave as a yield material, that is the elastic to plastic transformation, and the intermolecular structures as well as the differentiation values may get differs with respect to the yield point values. So how this has been transferred to a plastic range with respect to the applied stress. So these are the after getting into the plastic range, a set of deformation occurs over the surface which will clearly intimate how the nature of force have an impact over the surface. Then we are furthermore increasing, it will go beyond plastic range and reaches tensile strength, that is the place where it reaches the maximum deformation state and it tends to break. Furthermore increase in this from this state will lead to a breaking stress. So this is the inference. So this stress strain diagram will majorly impact on any nature of solid as well as flexible materials. When we are looking forward alloys, how much amount of load can be provided to a material. When we are going for a construction, the nature of beam should be kept recording. So this is the one where most of the engineers will reliable about the nature of different perspective of material over a specific surface. Hope students have understood how stress will have an impact on the surface and the nature of strain occurs due to the stress and the different effects of strain from this class. If you have any queries, you can please raise to me. Thank you.